All right, we're back. My name is Seth Juarez. It's Channel 9. You're watching live coverage of the Build 2017 edition. We're in Seattle this time because I think it's cloudy here, and we try to do a cloud thing.
So people don't feel bad about not being outside.
Nice. This is awesome. So I have here the wonderful Mark Russinovich, CTO of Azure. How you doing, my friend?
Good. Thanks for having me on the show, Seth.
Well, you know what? Today it's all about questions for you. So if you have any questions for the CTO of Azure, just get them in there. I'll get them as many questions as we can. We only have a half hour with you. But I'll start with this. What is the most exciting thing for you as a CTO of Azure that came out? Well, not the most. One of them.
Yeah.
Pick one that you are really excited. There's too many. Which is the one you're excited about to talk about today?
Well, I would say one of the big ones is Cosmos DB. Big announcement yesterday about that.
So tell me a little bit about Cosmos DB. Is it the evolution of document DB? Is it something else? Tell me about that.
It is the evolution of Document DB. It's obviously a rebranding. So Document DB is or Document DB SQL, I guess we're calling that API now, is one of the APIs supported by it. But and it had already document database, that infrastructure had already supported MongoDB.
Right.
Now we introduced the support for table API, but it was trying to get this story out of this NoSQL infrastructure that supports these different disparate API sets, but has capabilities that we think are uniquely differentiated with respect to any other cloud NoSQL solution.
So let's talk about what those differentiators might be, because one of the things that I heard about with Cosmos DB, and you can correct me if I'm wrong, is that you can target it as if it was MongoDB, or as if it was table storage, or as if it was a document DB itself.
Yep. So that's one aspect of it, is this different APIs that it supports. But underneath, you've got the exact same engine supporting that. And the engine is where the really true unique differentiation comes from, including things like extremely tight resource governance on every single API, such that we can provide SLAs, really strict performance SLAs that aren't matched by anybody else in the public cloud. 99% of the writes, for example, are under 10 milliseconds.
How do you, because I heard that. As I've heard of SLAs of we're the 5 nines and we do this, but I've never heard of an SLA that says we guarantee this will work under this amount of time every time. How can you guarantee that?
By carefully engineering it and provisioning resources appropriately, and this very sophisticated resource governance underneath. Of course, if we provision resources for everybody very statically, we would be paying enormous costs, and that cost we'd either be losing money or passing that cost on to customers. So the only way to achieve that kind of performance SLA at a cost competitive manner, and we are cost competitive with other solutions that are in the same space out there, is to have a very sophisticated algorithms on load balancing and making sure that as servers start to get utilized, we can move things around to less utilized servers.
And I mean, I started studying distributed systems, and I was like, this is hard, right? And so I went into machine learning, right? Yeah. How do we, the sheer amount of engineering to make this work, can you talk a little bit about that?
Well, so if you take a look at DocDB, it's been under development for 5 or 6 years. So it's not like it just was born in the last few months and announced yesterday. It's really been an ongoing evolution of work. And at the bottom of that, we've got an infrastructure solution, Service Fabric, that provides a lot of the low-level plumbing and support for this. And Cosmos database is built on top of that. So it gets some of its properties just from being built on top of Service Fabric, and then it brings some of its own data-specific capabilities, again, that it can layer on top of the infrastructure. So the cool thing about this kind of layering is that the DocDB or Cosmos DB team didn't have to go invent everything from scratch, like load balancing, like the ability to do rolling upgrades with zero downtime so that they can provide this SLAs even in the face of updates to the database.
And that's
be able to keep server failures transparent as possible.
I guess that speaks to sort of the value of Service Fabric as well, because if you can guarantee those kinds of things and it's running on top of Service Fabric, if you want to build on top of Service Fabric, you're also going to get some really nice properties too, right?
Yep, and exactly. We had some announcements about Service Fabric yesterday. Service Fabric that we make available, that we brought out GA last build, is the exact same bits that we're running internally. So the Service Fabric you get when you go to Azure and say, create me a Service Fabric cluster, or you get the Service Fabric SDK and you install it, those are the exact same bits that are powering the state replication underneath DocDB. And you can install it on your own servers. You can install it in a different cloud. You can install it on Azure, and you're getting bit for bit things like DocDB, Intune, Cortana, Service Bus, Event Hubs, the core Azure infrastructure. All of them are using these same bits.
So I want to talk about Service Fabric a little bit later too as well. But there's tons of questions coming in about Cosmos DB. How does Cosmos DB differ from other DBs? I think we spoke to that a little bit. SLAs are really a big differentiator.
Yeah, but there's another couple of big differentiators. One of them is the support for geo-replication. So you can have your database replicated across multiple regions.
Wow.
And completely transparently click a switch and then have traffic get routed to the closest location or the one that you want to be the primary. So that's one differentiation, is just that turnkey geo-replication, so I can survive natural disasters, for example,
right.
or I can survive problems of other types. Another one, though, is, and I think this is really where the computer science differentiation shows up in a way that makes it practical and consumable by different applications, is the consistency models it supports. So it supports 5 different consistency models, and of course, most people are familiar.
With CAP, right? With CAP theorem.
Kind of CAP. Like there are trade-offs, of course, when you choose different levels of consistency. The fact is that almost all databases that have been in commercial use to now have supported either strong consistency, which means everything is strongly ordered,
transactionally,
such, or eventual consistency, which means, eventually things will look the same and the replication will happen. What DocDB brings is in 3 intermediate, it's hard to get used to the name.
I know, we're going to get it.
Yeah,
we're going to get it.
We're going to get it. But it brings in 3 intermediate levels of consistency that kind of give you something where you can tune the level of consistency for your workload, rather than have to go to these either two extremes. Either, very simple for me to understand as a developer, but I pay a performance penalty, or very hard for me to understand and deal with as a developer. Eventual consistency. Some things might show up at different times in different places, but great performance because I'm not waiting on things.
So, how do you do that? Can you speak to the different levels of consistency? Because to me, it was always, well, you're either transactional or you're not. Yeah. How do you do this in Cosmos DB?
Yeah, so the levels of consistency, there's bound and stateless, there's prefix consistency, and there's session consistency. And if you take a look at bound and staleness, which is the closest to eventual, that makes a guarantee around when things will converge. So if I make a write, all the replicas will get the write within some period of time. And so now I don't have to guess.
Wonder,
how far out of date am I? Now with bounded staleness, I know exactly how out of date I can possibly be.
And you putting a number in there?
Yeah, we put an SLA on the bounded staleness.
Holy
as well.
Cow.
Over on closer to the strong consistency, session-based consistency, because most of the times when you talk about a database, there's different clients parting on the database, different parts of the database. In most cases, you just want somebody that writes something in one place to be able to see what they wrote in a strongly ordered way from another location. Right. And these different clients are related to each other, and what we call as a session. And so you can say this session is strongly ordered and strongly consistent, but there can be lots of sessions independently operating on the database. Each one of them has their own consistent view, but with respect to each other, there might be inconsistency.
There might be some. That's amazing. It's almost like you went in there in the CAP theorem and made a slider for consistency.
Yeah, exactly.
Which is pretty powerful if you think about it.
And and actually, if somebody's interested in a little bit more on this, I think one of the testaments to just how revolutionary bringing these types of consistency out and making them available for developers to be able to use when appropriate. Leslie Lamport, who's a Turing Award winner and one of the pioneers in distributed systems and theory, he's got a video that he's done on DocDB and talks a little bit about the different properties it's got. DocDB, of course, and all of our distributed systems owe a lot to the work he's done. So having him say, this is cool stuff, I think is really strong endorsement. He does work for Microsoft, so we do pay him to say this kind of stuff. But
when he was making these videos, he emailed me, and I was like, oh my gosh, I have an email from Leslie Lamport directed to me.
Yeah.
I didn't even know how to respond. How do you respond to someone like that without sounding dumb? I don't know what to do.
Hero worship.
I know.
Sure.
Next one, any plans to have Cosmos DB to be emulated with Azure Emulator for debugging?
Cosmos DB does have a local emulator, so I'm not sure if that answers that question. Maybe whoever's asking it's not aware that there is a local dev experience for it that you can run on your own box. So that kind of
makes sense, right? Because you can do a local emulation of Service Fabric.
Yeah.
So it would be natural to expect that you could do that Cosmos DB on top of that too. Awesome. Next, any plans to improve the speed of provisioning Windows Server in Azure to bring it under 5 minutes?
We are constantly working on improving the speed of deployment. I think if you look at the speed, if you look at where VM deployment was a year ago, 2 years ago, even 3 months ago, there's been improvements, and there's more to come. We'd see VM deployments for Linux, for example, down in the 45 to 60 second range right now. So, and we're still working on other enhancements. So we're driving that down on both operating systems as far as we can.
Wonderful. Al says, will Cosmos DB support more query operations than DocDB like count?
I don't know what the specific roadmap is for query. So Cosmos DB is effectively DocDB. It is that relabeled, rebranded.
But with more guarantees.
With more guarantees, right? It's got the SLAs across all 4 dimensions. We consider them: availability, reliability, consistency, and performance. And so will it support more? It's always evolving, so it's always going to get new query operations. So I don't know what the timeline is for that one. But
awesome. Next, and this I think we'll speak to that. We spoke to this already, and I think it's important to emphasize this. But when do I choose Cosmos over Document DB? Maybe you can sort of re-explain about.
I think this might be a little bit of confusion around the rebranding, because we did rebrand, and so Document. If you look at it from a developer perspective, DocDB is an API, and Cosmos DB is the name for the umbrella service that has all of these consistent guarantees, because it's all built on some of the same infrastructure, offering different APIs. So the question of, is DocDB, how's that different than Cosmos DB? It's the same thing.
Right, except better. It's like the evolution of Cosmos DB. All right, next question. Is it true that an on-prem Service Fabric cluster may never recover from a quorum loss after a complete power failure? I think maybe we should describe what maybe quorum is, and then talk to this as well.
Well, so quorum loss is quorum is an M of N type of situation where you vote and it's
a majority.
It's a majority of some degree of majority have to acknowledge commit for the overall transaction to be committed. In the case of Service Fabric, you can pick your replication level and you can pick your quorum level. Typical, kind of scenario would be I've got 5 replicas, so my quorum min is 3. If 3 respond positively, then I commit. So the question is, a total power failure, would I ever lose quorum? You shouldn't, because if recover after a complete failure. Never recover. You should always be able to recover if you've from at least the quorum committed set of operations should recover. I mean, that's the whole point. Is I've committed to 3. In fact, I can lose a couple and I can still recover off that single last replica. Now, I think the reason that you want, why do you have 3 out of those 5? There's a few reasons. One is availability, and the other one is durability. For availability, if you've got quorum of 5, you can actually lose a server while you're in the middle of an upgrade, so another instance is down, and you still have the ability to commit a quorum of 3. Now, from a durability perspective, you typically want at least 3 copies to be durable, so that you can lose a server and still have a couple copies to go recover from. But like I said, you could go all the way down to 1. So if you've committed quorum level transactions, you should always be able to recover. And I'm curious to know
at least the ones that were agreed upon by the quorum, right?
That's right.
If there's some that are floating around,
they're lost.
They're lost. Got it. Okay, next, will we see a replacement for Remote App? What's Remote App, first of all, and then will we see
so Remote App was basically it's remote applications, VDI type of service in Azure. And the question is, will we see a replacement? What we've done is actually partner with Citrix to be our VDI preferred partner. And so, not that there's not others, but that's really now our strategy is partnering with companies like Citrix to provide VDI services on top of us.
It's called the not invented here syndrome in programmer land, I think.
Yeah.
I mean, you know this,
Yeah.
right? And so will we see a replacement?
Not from Microsoft.
Okay, good.
Yeah.
Awesome. All right, next one. How about data encryption? What are the types on Cosmos? Is there encryption on Cosmos DB?
So actually, I'd have to go look to see where we are on different types of encryption.
Mm-hmm.
The strategy for us is the obvious one, which is all of our services provide encryption at rest.
Right.
Cosmos DB, I'm not sure if they already do it or not, and so it very well could already. It's hard to keep track of all these different releases, but the strategy further is that we will provide server-side encryption transparently. Many of our services support client-side encryption through the libraries and SDKs, like
Sure.
SQL does, for example. SQL always encrypted. And we'll also are introducing bring your own keys,
Got it.
customer keys for encryption as well. So it's just a matter of time before all of the services have the same kinds of support for encryption.
Awesome. Next one. Could one have a service fabric cluster of microservices aligned to the same geolocation of Cosmos DB geolocation?
So when you go create a service fabric cluster, you specify the underlying infrastructure.
Right.
When you go to the Azure portal and create a service fabric cluster, you specify the region that it goes into.
Right.
Today, we don't offer the ability for you to turnkey create a service fabric cluster that spans regions, but that you can imagine that something we're working on.
I don't know. Like I thought about this because someone brought this up to me. If you're doing a microservices implementation on Service Fabric, I don't know how. I mean, I understand replication for durability, right? But I don't understand replication. Like, why would you have one microservice database be in China and the web app be in North America?
Yeah, you typically wouldn't. I think if I understand the question correctly, Cosmos DB allows you to replicate across regions.
Got it.
And so you want your microservices to be also able to move around the region so that if there's a failover or if the primary you want to move for whatever reason, you switch regions that you want your microservices to be close to that data, not accessing it from another region. Cosmos DB itself is built on service fabric rings in each region that communicate with each other.
I see.
So that's one way to support that. But really, I think what the question is asking is, can I create a service fabric ring that spans these regions and have the microservices move around them? Like I said, you can do that. You can set it up manually. There's no turnkey way to do that today.
Okay. So now I think we have about 9 minutes and a half or so. I wanted to move over to this idea of service fabric because I have a hard time, and maybe this is just me and I'm dense, I'm having a hard time differentiating between the stuff we offer in ACS, Azure Container Service, and Service Fabric. Maybe you can sort of set the landscape of what's available because there is a great number of choices that one can make. So why don't you lay that out for us?
Yeah, and I think this is one of the unfortunate side effects of us being a platform that wants to meet customers wherever they are and give them the choice to pick whatever technology that fits their needs and requirements best. If you take a look at Service Fabric, that is our first-party microservices platform. We're focused not on just primitive orchestration, but on higher-level microservice application building.
Like data structures
like
and stuff,
data
right?
structures, like programming models, like object-oriented microservices that you see with the actor model, for example. And you'll see more programming models come into play. The fact is that we believe that just orchestrating executables or containers is not where developers want to be.
Right.
They want to be up at, I'm worried about the application. And so that's where Service Fabric, that's where it started. That's where and North Star was originally. If you look at the announcements yesterday around container orchestration that we made around Service Fabric, the GA of Windows Server container support, it is to say that we understand that containers are the de facto way now people are packaging up their code and isolating their code, and so Service Fabric supports that. We're also saying that if you are interested in a microservices platform with these programming models, that doesn't mean that if you've got some containers that are just simple lift and shift type containers, that you have to go find a different solution and break your application apart and say, this part runs on this orchestrator over here, the rest of my microservices run on Service Fabric. What this does is bring basic container support into the Service Fabric application world. And so now you don't have to make a choice. You can have an application that consists of reliable collections, standard executables or DLLs, actors, as well as containers that to deploy. And all of those, you're in the same tool chain, you're in the same model, you're in the same clusters, you're managing the same resources. And so it's a very consistent world. And you'll see that that's what Service Fabric is, from these primitive layers all the way up into abstract programming models. Now, the relationship between that and ACS. ACS is the brand that we've got for our containers as a service offerings, which include the container orchestrators that we see customers using.
Like Mesos,
and
Kubernetes,
that they want to bring into the cloud, right? For whatever reason. Maybe they've been using Mesos for several years in production on-prem. They want to move to the cloud. They want to continue using Mesos.
That's great.
That's fantastic. And so this is our way of supporting them, trying to make it easy for them to not have to worry about the provisioning and maintenance of their Mesos cluster. That's something that Azure Container Service would do. So it's really, I know it's confusing if you just come at the platform, but I think that's the way to look at it is application, microservice platform, and Service Fabric works for Linux, works for Windows, works on-prem, works in the cloud. It is built on, powers a lot of Microsoft services, including some of the ones we've talked about, and then the other third-party orchestrators that we want to be great at supporting because lots of our customers want to use those.
So I'm trying to understand, is ACS sort of an overarching thing, and inside we have Kubernetes, Mesos, Docker Swarm, and also Azure Service Fabric?
So Service Fabric isn't under that brand because, and that is just a side effect of the fact that when when we created ACS, Service Fabric didn't support containers. Now it supports containers. Also, ACS was meant to be this is our open source supported offering platform where we're basically running these things as managed services for you. Service Fabric isn't open source at this point, so it's kind of a little bit different, and it's also focused on microservices, not just containers. So I think that we've got some cleaning up to do on the labeling so that people are less confused about, hey, if I want containers, I look at Azure Container Service for that when Service Fabric is over here supporting containers.
Yeah, and I like the idea of looking at Service Fabric as a container orchestration now that we have containers, plus some data structures. Because data structures in a distributed system are hard.
Yeah,
it's not something that I want to be coding ever. So if it's something that I could already get, for example, tell us what were some of the distributed data structures that are available in Service Fabric?
So dictionary is one of them. Queues I don't know if queues are out yet, but queues are another one. So dictionary being key value store, and actually the primitive of key value store supports a ton of different data structures you can build on top of that.
And to me, that was always hard because anytime I thought of a distributed system, I'm like, where does the data go?
Yeah.
Right? And when you're looking at a microservice, you're like, who owns the data in that microservice? Clearly, it's the microservice, but then how do we get things over to the right place? And it was really hard for me to understand that. And then once I learned of Service Fabric's ability to have these distributed data structures, it made a little bit more sense, right? Because now you're sharing these things.
Yeah, and to be clear, Service Fabric supports both stateful, and which we just talked about, and stateless, because not all of your microservices are going to be managing state.
Of course.
And in fact, the model of I've got stateless microservices, and then I'm storing state in Cosmos DB or Azure Database, SQL Database, or Azure Storage, that's perfectly well supported by it. I still get the microservices model and programming models. The reason why somebody might want to put state into their microservices is low latency, high throughput, instant failover. So if you want the highest levels of reliability, availability, durability, this is and performance. This is where we see that. So backend for IoT, gaming platforms, those are some of the scenarios that we see Service Fabric really shining. That's stateful stuff.
And I love how we've embraced the fact that things will break.
Yeah.
And so we optimize for failure.
Yeah. In fact, Service Fabric has its own little Chaos Monkey support in it. So
nice.
You can hammer your microservices and make sure that they survive.
That's kind of cool. I've always wanted to break stuff. I mean, it's really fun to do that. We only have, I can't believe we literally burned through all our time.
Wow.
Let's go through some more questions.
Okay.
Do you see Service Fabric offering better support for guest executables in the future? They don't get the same amount of service context information provided at runtime, or have REST clients available in other languages?
So that's... I need to go back and look at that and see what our roadmap is. There hasn't been a lot of focus on guest executables because it's been mostly focused now on just getting the container support in as well as the programming models. Guest executable support's kind of this in the middle thing, so I don't know if it's gotten attention lately, but I'll take that back and see what we're doing there.
Awesome. And next question, do you consider something like Service Fabric as a service a preset infrastructure hosting, smaller projects, or for testing? Like when, I guess the question, I'm looking at this, it feels like, when should I think about Service Fabric as something that I need to do?
Yeah. When should you think of it as something you need to do?
Well, like kind of applications. How do I, there's always like a code smell when I'm like, I should probably make another class, or this should be an interface. Is there like a project smell that tells us we should go microservice, Azure Service Fabric?
So I think, yes, if you're going to go microservices, if it's something that's not just trivial web plus database, if it's something a little more complex, if it's something you know is going to continue to evolve and become more complex, you definitely want to start with the microservices mindset off the bat, because otherwise you end up with a monolith and then you end up with this hard problem of decomposing it. If you've got a project with lots of teams contributing to it, microservices is another.
And what if you have a monolith and you're like, this is not working? What path do you see? What road should I take to sort of break it up into microservices?
So I mean, it's going to depend on the project, but I think what you want to do is find the parts of the core logic that manipulate data very tightly, because what you don't want is to break it up into very chatty communications links, because then you're going to kill performance. So, and you also, I think, need to identify your state and break apart your state and say, this components own this state, because part of microservices successfully is creating interfaces that manipulate state rather than letting direct manipulation happen, which is in the monolith, everybody parties on the state. So saying, here's the state clusters, and then building microservices around that.
That's awesome.
Yeah.
Okay, we have 10 seconds. Most important question. Here's a non-technical one. How tall is Mark Russinovich?
Last I measured, it was about a little over 6'5". So
it's a tall dude.
I think I'm shrinking as I get older. So.
Thanks so much for spending some time with us. Thanks for watching. We'll see you after this break.